Okay, continuing 1.3 part 2. So determine whether f of x equal to 1 over 2x plus 1 is continuous at x equal to 1 over 2. Justify using the continuity test. So if you have a graphing calculator available, you can just graph this using graphing calculator. So if you do it, it looks like this. So if question was right here, when x equal to minus 1 over 2, then your answer should be discontinuous. So you might say, how did you know minus 1 over 2? I let the denominator equal to 0. Do you remember the domain condition? X denominator cannot equal to 0. So if you let 2x plus 1 equal to 0, solve for x, you will end up with x equal to minus 1 half. So this graph will be discontinuous at x equal to minus 1 over 2. But this question is asking about x equal to 1 over 2, positive 1 over 2. The positive 1 over 2 is somewhere over here. There's nothing going on. It's a nice smooth curve here. So you should know that it should be continuous. The answer you already know by looking at the graph, it's continuous. We are not done yet. Why not? Justify using continuity test. So do you remember continuity test is condition 1, 2, 3. You have to show that. So how do you show f of c exists? Plug it in. 1 over 2, plug it in 1 over 2 for value of x. So if you have a graphing calculator, definitely take advantage of it. So first condition, f of 1 over 2. Plug it in wherever x appears. As 1 over 2. Plug it in 1 over 2. Then put that into the calculator. Then you will get the answer. When you do put that into the calculator, make sure you always make a habit of a parenthesize, numerator, denominator. Numerator is only one number here. So parenthesis, you don't need a parenthesis, but sometimes it's not. So it's always safe to put parenthesis on numerator, parenthesis on denominator when you type into the calculator. Then you will never lose it. So if you calculate that manually or using calculator, you will get answer of 1 over 2. So if you do it, you get 1 over 2. So check mark. First condition satisfied. Second condition is limit. Does limit exist? Limit f of x as x approaches to 1 over 2, as x approaches to 1 over 2 from left-hand side, right-hand side, does limit exist? Okay, how are we supposed to check that? So you can do some table. So x is approaching 2. X is approaching to 1 over 2. 1 over 2 is 0.5. So approach to 0.5. So I made a gap of 0.01 gap from 0.5, left and right. So I did 0.5 minus 0.01, 0.5 plus 0.01. So they are very, very close to 0.5. Their only gap is 0.05, 0.01 gap, 0.01 gap. I also did a little further, 0.1. So I did 0.5 plus 0.1. I did 0.5 minus 0.1. So these gaps are 0.1, 0.1. These gaps are 0.01, 0.01 gap. So it's kind of getting closer to 0.5. So I got those x values, plug those x values into the function, and I calculated y value using calculator. So 0.4, I plug it in 0.4 for x value here. 1 over 2 times the parenthesis 0.4 plus 1. Of course, parenthesis. I use the calculator, plug the x value, y value. Plug x value, y value. How does this help us to determine the limit? So as x value approaches to 0.5, look at the y value. Is y value approaching to certain value? So this is from the left. So it's approaching to here, approaching here to here. They are approaching to 0.5. So limit value does exist. Limit of f of x does exist, which is equal to 1/2. So I say limit of f of x as x approaches to 1/2 does exist, which is 0.5, which is 1/2. And the third condition is limit value equal to function value? Is that equal to this? Yes. So third condition is the limit of f of x as x approaches 2, is that equal to 1/2? I mean, f of 1/2. Is that equal to this? That's the question. Yes. So continuous at x equal to 1/2. Okay, so you should try this by yourself. Pause it and try it. Okay, if you have tried, the answer should be continuous. If you graph this using graphing calculator, it will be parabola open up. It will be smooth, nice curve. There's no discontinuous everywhere. So n x equal to 1, if you check it, you should know, yeah, it is continuous. You should be able to tell. Well, continuity test is a different story. So first thing, what do? Plug it in f of 1. Well, plug it in 1 for value of x. So 1 squared plus 2 times 1 minus 3 becomes 1 plus 2 is 3 minus 3. It becomes 0. Check mark. It does exist. Second is limit. Limit of f of x as x approaches to 1. What is that equal to? So for that, you might have to do some table here. X equal to 1. I made a gap of 0.01 left and right from 1. I made a gap of 0.1 from 1 left and right. I plugged x value, I used the calculator. I got all the y values. So take a look at it. So y value is approaching to this, y value is approaching to this. Is y value approaching to a certain value? Minus 0.03 is almost 0. Minus 0.04 is almost 0. If you do little closer, 0.999, 1.001, if you make the gap even smaller, it will be almost 0. They are approaching to 0. So second condition, is it does the limit exist? Yes, the limit does exist, which is 0. Third condition, is that equal to this? Yes, you can use this, you're looking at it. Limit of f of x as x approaches to 1, is that equal to f of 1? Are they matching each other? Yes, 0, 0, they are matching. So you say continuous at x equal to 1. Okay. All polynomials are continuous everywhere. So if you have a polynomial, then you can say it's all continuous. But when I ask you continuity test, well, that's, you have to condition 1, 2, 3, and that's what you have to do for continuity test. Okay, determine the function is a continuous at x equal to 1. Justify using the continuity test if discontinuous. Identify the type of discontinuity at infinite jump or removable. So not only you have to say discontinuous continuous at x equal to 1, if it's discontinuous, you have to say what type. Is it infinite jump or removable? So this was infinite discontinuity, and this was jump, and this was removable. This was removable. This was infinite discontinuity. So easiest way for you to tell will be graphing this first. If you graph it and let denominator equal to 0, which is x equal to 1, so you know from the start, okay, x equal to 1, it should be discontinuous. If you have graphing available here, like this, you know it's the infinite discontinuity. It's like this. Okay? But here, justifying using continuity test. So you already know, if the graphing is available, you already know it's a discontinuous set x equal to 1. What type of discontinuity? It's infinite discontinuity. But justifying using continuity tests, you have to do condition 1, condition 2, condition 3. Okay? So what was the condition 1 again? F of c exists. How do you do that? F of 1 exists. So you have to plug it in 1. So continuity test, you have to plug it in 1 for value of x. So 1, plug it in 1 for x, you get 1 over 0. Denominator cannot equal to 0. So it's undefined. Undefined. So f of 1 does not exist. So busted. It's a discontinuous. So discontinuous at x equal to 1. But now, if it is continuous, you have to say, what kind of discontinuity is that? So that's this question. Is that infinite? Is it removable? You already know it's infinite by looking at the graph, but how do we do that algebraically? So for that, you will have to plug it in some table values. So 1, x equal to 1. So you will have to plug it in close value to 1, 0.99, 1.01. I made a gap of 0.01. And 0.1 gap will be 0.9, 1.1. So you will have to plug x value. You have to plug in x value, plug in x value, plug in x value, and try to get y values. So x and f of x (0.9, 0.99, 1.01, 1.1). So you plug into the this equation. So f of x equal to 1 over x minus 1. So I'll use a graphing calculator. So if you plug it in this, I get minus 100. I got 100 here. I got minus 10 here. I got 10 here when you plug into the calculator. Okay, so it tells you as x value get closer to 1 from left hand side, right hand side, the values are changing a lot. It used to be minus 10, now it's minus 100, so you know it's keep going down. It used to be 10, now it's 100, so it's keep going up. It's keep changing very, very rapidly. So that's another way to look at Yes, it should be infinite discontinuity, not removable discontinuity. Okay? If it was removable, this value will be very close by. It should be like 99, it should be like minus 99, not like this big gap. So infinite discontinuity x equal to 1. Okay, same style. Determine whether the each function is continuous at x value. So it's two different points. Excuse me. They want to check this at x equal to 1. One question. They want you to also check that x equal to 4. And also say what kind of discontinuity. So x equal to 1. You will have to plug it in x equal to 1. So let's deal with x equal to 1 first. What do? Plug it in 1 for value of x. So you will have to do h of 1. So it should be 1 minus 4 all over 1 squared minus 5 times 1 plus 4. So if you have graphing calculator, type that in. If you when you type into the graphing calculator, make sure you have a parenthesis here, parenthesis here, parenthesis for numerator, parenthesis for denominator. Make sure you do that. Then you get what? Minus 3 over 1 minus 5 plus 4, that's a 0. Aha. Again, denominator is 0, that's a trouble, undefined. So right then you can say discontinuous. Discontinuous at x equal to 1. Busted. First condition is not satisfied. Okay, now say what kind of discontinuous? So you want to plug it in nearby value for 1. So I did this table already. So if you look at it, I wonder if this is this was a previous question, isn't it? Let me just double check. Oh, yeah, if you will become the previous question. Okay, so if you plug it in x values as the following, you will see, just like previous question, it's very high here, very low here, and the values are changing rapidly. So you know it's kind of this kind of situation. So it will be infinite discontinuity. Now x equal to 4. So first condition you have to do is x equal to 4. You will have to plug it in. So h of 4, plug it in, should be 4 minus 4 all over 4 squared minus 5 times 4 plus 4. You can put it into the calculator. Should be about 0 over 16 minus 4. That's a 0? Yeah, so 0 on numerator is okay, but 0 on denominator, so it's undefined. It's undefined. And you say this continues. At x equal to 4 as well. Then you say, well, what kind of discontinuous? So if you look at the graph, the table, I did around the 4 here. If you look at the y value, it's approaching to 0.334, 0.33. It's approaching to 0.333, which is close, very close value. So they are getting closer to 0.333. So you should know it's not this kind of discontinuity. it's this kind of discontinuity, which is removable. It's left hand limit, right hand limit, they are close by, so you should know that has a hole, and that's a removable discontinuity. So that's why you say this is a removable discontinuity. Again, for this kind of a question, you just not using the discontinuity test. If you just want to get an answer by looking at the graph, you can graph this equation using calculator. So let me show it to you with my calculator. So I'm going to type x minus 4 so if you graph it, so I don't know if you can see clearly. So x equal to 1 is somewhere over here. So you know x equal to 1 should be infinite discontinuity. X equal to 4, 1, 2, 3, 4. 4 is right here. So there's no infinite discontinuity, and there's a hole. Usually calculator cannot show you a hole, and that's where the hole is. When x equal to 4, the function wouldn't be identified. So by looking at the graph, it's fairly simple for you to say it's infinite discontinuity or removable discontinuity. But when I ask you to use a continuity test, even though you know the answer by looking at the graph, you still have to do discontinuity test. Intermediate value theorem. Okay, so if f of x is a continuous function, and let's say x value a is less than b, there is a value of n such that n is between f of a, f of b, then there is a number c such that c is between a and b, whose matching value is f of c. Okay, it's very mathematical. You might say, wow, that's hard to understand. So basically, this is what they're saying. There is a value, b value for value of x function. So there would be some matching value of a on our graph, whatever the matching value f of a. The matching value of b, whatever matching value of f of b. So there's a point here, there's a point here. When you say it's a continuous function, that means they are connected somehow. They are connected. So fancy way of saying that is, if you choose any value of y between here, let's say n, then there gotta be matching value on that graph, and that x value has to be between a and b. That's all they are saying. Yeah, that's so possible. So it's a fancy way of saying you cannot have a graph like that. That's not possible because when x equal to n, there's no function value of x matching it. Well, then it's not continuous. Somehow you have to connect them. That then means if you have n value for y, there gotta be matching value for of c, which is between a and b. That's what they are saying. Corollary to that is even easier. They are saying if function value for a is negative, if a function value of b is positive, then there gotta be 0, which means x-intercept somewhere between. Yeah. Somehow you have to connect these two points. To do so, you have to cross x-axis somewhere between. You cannot just jump the x. You have to cross x-axis somewhere. That's what they're saying. There gotta be some x-intercept between a and b. If one is negative function value, one is positive function value, you have to cross x-axis somewhere between a and b. That's what that statement is saying. Okay, so that statement was a little confusing. Some of them might say, what? Well, it's not that bad in application. Determine which between which consecutive integers the real zeros of f of x equal to these are located on interval -2 to 2. So what are they talking about? They're asking between what integer to what integer do we have x-intercept? 0 means x-intercept. So if you have a graphing calculator available, if you can graph it, you know it's between what? -2 and -1. It's between -2 and -1. Done. And the answer should be between -2 and -1. You can say between -2 and -1. Or x is between -2 and -1. What if the graph is not available? What if you don't have graphing calculator? And what if they gave you this table? So this table gives you all x values are integers and y values. It's pretty simple. You're just looking at x value between in which y value changes its sign. Okay, y value, look at it, minus, y value, look at it, positive. It changed the sign from y value from minus to positive between right here. Well, the answer is this then, between -2 and -1. That was our final answer, -2 -1. So y value positive to positive didn't change. Positive to positive didn't change. Positive to positive didn't change. If sign didn't change, everything is okay. It's not positive, positive, everything is on one side. But if you look at the -2 here, y value was negative, y value was positive. That means there gotta be x-intercept between these x values. That's all they are saying. So given this, solving it by looking at the graph, piece of cake. You know it's passing where it's passing. You can say the zeros are between -2 and -1, done. Also, by looking at the table, it's not that bad. Just look for the sign change from plus to minus or minus to plus in y value. And your answer should be x value to x value. So that's the answer here.